Hi, and welcome to Econometrics. This series is going to dwell with econometrics, but we are going to just brush upon the regression analysis. If you need to dig deeper into the knowledge of regression analysis, then you should check out the video series, the playlist at 2200. Which is on this YouTube channel. Okay, so without further ado, let's get to it. We are going to talk a bit about regression analysis because regression analysis is the workhorse of econometric analysis. So what we want to do is look at the big picture. Okay. This lecture note or this lecture series will provide a review of linear regression with one regressor, and we are following Stock and Watson, Introduction to Econometrics. And this week we are looking at chapters 4 and 5. So, and as always, videos cannot fully replace reading the book because, let's face it, if you read every single word in the book, it takes quite a bit of hours, okay, if you read it out loud, okay? So, these videos will give you a certain overview of the main concepts from the book. Okay, so regression analysis, it's really a statistical method that you use to find a linear relationship between several variables. Often you would have like a y variable and you would have an x variable. In the case of simple regression model, you only have one x. When we go to multiple regression, then you have more x variables, okay? And you have some data on the y variable and the x variable, and they might look something like this, okay? And regression analysis actually just picks the linear function which minimizes the distance between, or the square distance between the line, which we call y hat because it's an estimate, and the data points themselves, okay? And why do we do this? Well, we do this because we either want to use this model for predictive modeling or causal inference, okay? So what we do is that we focus on different parts of this model, different parts depending on what we want to use it for. And there are different methods of regression analysis, but here in this class, we are focusing on the linear regression model. So this line here might be something like this with an intercept, right? The intercept is here, and you have a slope which we call beta 1 hat, and we have the x, okay? So this is the estimated line. And linear means that it's linear in the coefficients, and here you find the coefficients. So these beta beta hat, they are the coefficients, okay? And the x is the variable. So, and the y is also a variable, okay? So, important, the linear regression model is linear in the coefficients because the coefficients they are not in anything else than the power of 1, okay? So you do not have like beta hat squared or the logarithm of beta, but you can have nonlinearity in the variables. So for example, the x variable or the y variable can be transformed into the logarithm of y, or y to the power of 2, for example. So that's the difference between coefficients and variable, okay? And linear regression is linear in the coefficients. So what is predictive modeling? Well, it's actually the process of estimating a model based on your data, and then you use your model to predict non-observed y's, okay? So for example, you have this model, simple linear regression model, and what you have is that based on your data, those dots from the previous slide, you have this estimated model, okay? Estimated linear model. And what you can do is that you can just, if you want to predict a y variable, you can feed into the model a new x value, and you can just use your model and get like a y hat new, okay? So for example, the police department in Santa Cruz, California, implements predictive policing, okay? What they do is that they fit a model based on historical data of crime in certain areas and other predictors of crime, and they try to estimate the crime rate in the future based on that model, okay? So what they do is that they have this model. Maybe it's a time series model, maybe it's a panel data model, I don't know. But what they do is that, for example, for a time series model, you have this estimated model, you have some old data, and then you try to predict the future future values of this y time series, okay? So what you do is a predictor or a prediction into the future is called a forecast, okay? So for example, predictive modeling can either be a forecast, okay, this is an E, forecast, this is an A, is into the future. Or you can have like a prediction, it's like a prediction now, okay? So that would be predictive modeling. Okay, you use your model to say something about a new instance now or a new instance into the future. And we're coming back to this later on in the course. So what about causal inference? Causal inference is a bit different, okay? Because now you're not interested in how well the model is predicting something. You're interested in what is predicting the y variable, okay? What is a partial cause of the variation in the y variable, okay? So what you're interested in is the regression model, okay? So you have the regression model. You're not interested in plugging in to the x, like data into the x, and get like a prediction, the y hat. You're interested in this coefficient, okay? This coefficient. And often you're interested in the slope, not the intercept, okay? This is the, oops, let's see if we can get this right. Okay, so often you're interested in the slope, and in causal inference, you're interested in, is this slope or this intercept, are those different from zero? Okay, are those different from zero, keeping everything else equal? Okay, keeping everything else equal. So what you do is that you often perform randomized controlled experiments, and this is a procedure where you randomly assign units to either treatment or to control groups. Okay, so for example, you can put this. Well, you have some instances. Okay, you have some instances, and you either put them in one group of treatment, okay? For example, and we have this chocolate eating control here, or group here. So these in the treatment group, they eat chocolate, okay? So they eat chocolate, and those in the control group, they do not know chocolate. Okay, so these are these people. They are picked on random to be a part of each group. And in this example, we are looking at, does the eating of chocolate reduce your cholesterol level? Okay? And you might think that, well, a lot of things affect the cholesterol level, so what you want is that this randomization, it removes any difference on average between of any metric which might differ between the groups. Okay, what you don't want is, for example, maybe people who eat chocolate, they are also richer than other people who do not eat chocolate, maybe dark chocolate or something. And because they are richer, they can afford more healthy food or more education, which in turn improves their health, or maybe they can afford better health care and better medicine. So you want these two groups to be virtually equal, and then you want to assign a treatment to one group and no treatment to the other group. Okay, and that's how you can draw out causal inference, because then you could have one variable which differs between the groups, and you can look at the change between the groups of eating chocolate and not eating chocolate on the y variable, which in this example is the cholesterol level. Okay, so that's a tiny introduction. See you in the next video.